Hi everyone, Assalamualaikum. In this video, we are going to discuss example 6 under Newton's law of cooling in investigation. The question is, the CSI team arrived at the scene of a murder at 9:30 p.m. At that time, the dead body's temperature was 77.9 degrees Fahrenheit. At 10:30 p.m., the dead body's temperature was recorded again, and it was 75.6 degrees Fahrenheit. Given the room temperature was 72 degrees Fahrenheit, when was the person murdered? A normal human body temperature is 98.6 degrees Fahrenheit. Alright. First, from the information in the question given, we extract time and temperature. Alright. Now we extract one by one, okay, from the given question. Alright, arrive at the scene of a murder at 9:30 p.m. So we can write at 9:30 p.m. we assume T equals to 0. Okay, and then 77.9 degree Fahrenheit here means temperature. Okay, and then at 10:30 p.m. here means time. Okay, so from 9:30 p.m. to 10:30 p.m. it is 1 hour. Okay, so we can write 1 hour here. Okay, and then 75.6 degree Fahrenheit here means temperature after 1 hour. Okay, and then room temperature was 72 degree Fahrenheit here. We can put here 40 m. Okay, where Tm is temperature of room or temperature of surrounding. Alright. And then the word when here, okay, when was the person murdered, means we want to find time, T. So we can write T equals to question mark. Okay. Now this is time of death. Alright. And then from 98.6 degree Fahrenheit here means the temperature, okay, when the person died. Okay. Alright, and then from here, okay, from time and temperature here, okay, we reorder based on descending values. Okay, because when he dies, his temperature will drop. Okay, so we reorder based on descending temperature values, right, from here. Okay, right, T0 when 9:30 p.m. at 10:30 p.m. we write 1 hour, and then time equals to question mark means time of death. Okay, alright, so T here we will get negative value. Okay, because the time of death must be before 9:30 p.m. means before 0. So before 0 means T must be negative. Okay, and then 98.6 degree Fahrenheit here means normal human body. Okay, so when the person just pass away, so the body temperature is considered to be the same as normal human body temperature. Okay, so that's why we put temperature equals to normal human body when we want to find the time of death. Right? Alright, after we extract all information about time and temperature, okay, we can start the solution with d temperature over d time equals to k T minus Tm, right? And we're separating variables time and temperature, okay? So from over dt here, we can move to right hand side and it become multiplication. And then for T minus Tm, for temperature and temperature of room, we can move to left hand side. So we can write this. 1 over T minus Tm, d temperature equals to K d time, right? And then from here, we can integrate both sides. We just put integration sign for both sides. Alright, after we separating variables time and temperature. Okay, then we integrate left hand side and right hand side. When we integrate left hand side, we can refer from, let's say we have integration of 1 over x plus constant 2 dx. Then the answer equals to ln x plus 2 plus c. We can use u substitution, u equals to denominator here. Okay. Alright. If we have 1 over T temperature minus Tm, which is temperature of room, which is constant, so we can use the same technique. Okay. So the answer equals to ln temperature minus temperature of room. Okay. Plus C. But we just put plus C on one side only. Okay. And then to integrate K dt, we can refer from, let's say we have integration of 2x. Integration of 2 dx. Okay. 2 here is constant. Okay. So it is equals to constant 2x plus c. So when we integrate constant k d time, so we will get constant time, okay, kt plus c. Alright. And then now we need to write temperature as a subject. Okay. But we have ln here. Okay. So we need to move ln to right hand side. Okay. When we move ln to right hand side, okay, it becomes E. Okay. Exponent. So we have T minus Tm equals to E to the power of Kt plus C. Okay. And then from here, we can use properties of indices to separate. Okay. From properties of indices, A the power of m times A the power of m. Okay, we can add the exponent. Okay, so from here, okay, E to the power of Kt plus C, we can separate. Okay, to E the power of Kt times E to the power of C. Alright. And E to the power of C here, okay, we can write equals to constant C. Because E, which is Euler's number, equivalent to 2.718 something, which is constant, to the power of constant will become constant. Okay, so that's why we can write E to the power of C equals to constant C. Alright. And after that, we can write temperature equals to positive temperature of room plus CE to the power of KT. Right? Right, from the previous slide, we get T equals to Tm plus C e to the power of K time. Right? So from here, we can replace Tm equals to 72. Okay, from here. Right? Tm is temperature of room. Okay. Then after that, we can naming it as equation 1. Okay. Then we can substitute when T equals to 0, temperature equals to 77.9 degree Fahrenheit into equation 1 to find C. Alright. And we can substitute the last row to find K. Alright. Alright, to find C, substitute T equals to 0 and temperature equals to 77.9 degree Fahrenheit into equation 1 here. Okay. So from equation 1, okay, we replace T equals to 77.9. Okay, and we replace T equals to 0 here. And after that, E the power of 0 equals to 1. Then we can move 72 to left hand side, so we get 77.9 minus 72, so we get C equals to 5.9, right? And then we substitute back into equation 1 here, okay? Alright, so after we substitute into equation 1, okay, so we get T equals to 72.5.19 e to the power of KT. We substitute 5.9 into C here. Alright. Then we naming it as equation 2. Alright. Then to find K, okay, we substitute T equals to 1 hour, temperature equals to 75.6 degree Fahrenheit into the latest equation, equation 2. Okay. Equation 1 and equation 2 are the same equation, but equation 1, we don't know the value of C, and equation 2, after we substitute the value of C. Alright. Alright, so from equation 2 here, okay, we replace T by 1 hour, okay, and we replace temperature by 75.6. Alright. Then we get 5.9 E, the power of K equals to, we move 72 to left hand side, so we get 75.6 minus 72, so we get 3.6. Okay. Then E to the power of K equals to, we move 5.9 to right hand side, so we get 3.6 over 5.9. Okay. Now we want to find the value of K, and we have E here, so we can move E to right hand side. Okay. When we move E to right hand side, it becomes ln. So we get K equals to ln 3.6 over 5.9. Okay. And then using calculator, we will get negative 0.49401 up to 5 decimal places. Okay. And from here, we can substitute the value of K into equation 2 here. Okay. And before that, K equals to negative value because K is cooling constant. Right? So cooling is about the temperature will drop. Alright? That's why K under Newton's law of cooling will negative. Alright? Then after we substitute K into equation 2, we will get this. Okay? K here, we substitute by negative 0.49401. Okay? Then we can naming it as equation 3, okay, to solve the next question. Right? From the previous slide, we get temperature equals to 72 plus 5.9 e to the power of negative 0.49401 T. This is an expression for the temperature at any time T. Okay? And after that, we can find the time of death. We substitute temperature equals to 98.6 degree Fahrenheit, okay, into equation 3. Okay. So after we substitute T equals to T temperature equals to 98.6 degree Fahrenheit into equation 3, okay, we get this. Okay. Okay, from here, from equation 3, we replace temperature equals to 98.6. Okay. And then from here, we will move 72 to left hand side. Okay. So we get 98.6 minus 72. Okay. And then after we simplify here, so we get e to the power of negative 0.49401 T equals to, we simplify this, we get 26.6, and then we move 5.9 to left hand side, so it becomes denominator 5.9. Okay. Now we want to find T, time. Okay. So we need to move E to right hand side. And when we move E to right hand side, it becomes ln. Okay. So we get negative 0.49401 T here equals to ln 26.6 over 5.9. Right? Then, using calculator, we will get T equals to negative 3.04843. Right? And then from here, the unit given for time is hour. Okay? So, we can write hours here. right? And then to find the time of death, okay, so from t equals to negative 3.04843 hours here, 0.04843 here not equals to minute. Okay, so we need to change in terms of minutes. So how to change from decimal to minutes? Okay, first we separate 3 hours plus 0.04843 hours here. Okay, so decimal here we multiply by 60 minutes. Okay, then we will get 3 hours 2.91 minutes, or about 3 hours 3 minutes. Okay, so the time of that, okay, equals to from 9:30 p.m. okay, we minus 3 hours 3 minutes here. Okay, or 3 hours 3 minutes means 3:03 here. Okay, so the time of that equals to 6:27 p.m. okay, at the same day. Alright, then we can write thus the murder occurred 3.04843 hours before, the word before here because negative, okay, from here, okay, before 9:30 p.m. okay, and 3.04843 hours approximate to 3 hours 3 minutes here. Okay, so the murder occurred at about 6:27 p.m. okay, at the same day. Okay, because less than 24 hours. Okay, right? Coming up next, Newton's law of cooling. Applications of separable differential equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.